What is thermodynamics? Thermodynamics is the branch of physics that studies how heat, work, and temperature relate to energy and the physical properties of matter. It explains how thermal energy converts to and from other forms of energy, and how these processes affect systems under its four fundamental laws. 2. Definition. Thermodynamics examines macroscopic systems, called thermodynamic systems, and their exchanges of energy as heat or work with their surroundings. By focusing on measurable quantities like temperature, pressure, and volume, it provides a framework for predicting how systems evolve toward equilibrium. Key concepts. Thermodynamics centers on several core properties that characterize a system's energy and its interactions. Heat, energy transferred due to a temperature difference. Work, energy transfer when a force moves an object or expands a system. Temperature, measure of the average kinetic energy of particles. Internal energy, total energy contained within a system. Entropy, measure of disorder or the number of ways a system can be arranged. Laws of thermodynamics. The behavior of energy exchanges in thermodynamic systems is governed by four fundamental laws. Zeroth law. If two systems are each in thermal equilibrium with a third, they are in equilibrium with each other, defining temperature. First law, conservation of energy. A system's change in internal energy equals heat added minus work done by the system. Second law, entropy of an isolated system never decreases. Heat does not flow spontaneously from cold to hot. Third law, as temperature approaches absolute zero, the entropy of a perfect crystal approaches a constant minimum. Applications. Thermodynamics underpins technologies and sciences across disciplines. Engineering, design of engines, refrigerators and power plants. Chemistry, prediction of reaction spontaneity and equilibrium. Biology, energetics of cellular processes like ATP hydrolysis. Meteorology, understanding atmospheric heat transfer and weather patterns. Materials, science, phase changes, nanotechnology, and more. Historical development, driven by the quest for more efficient steam engines in the early 19th century, pioneers such as Sadi Carnot, Rudolf Clausius, and Lord Kelvin established the foundational principles of thermodynamics. Their work transformed heat from a mysterious fluid to a measurable form of energy and formalized the laws still used today. Beyond classical thermodynamics, statistical mechanics. While classical thermodynamics describes equilibrium states using macroscopic variables, statistical mechanics builds a microscopic foundation. By relating the motions and interactions of individual molecules or quantum states to bulk properties, it explains the origin of entropy and refines predictions for small or non-equilibrium systems.